Oh, silly me. I was running out of time, and I forgot what I was doing. I meant to go back up to this original problem that I gave you and work that now that we have this technique. Maybe I can just hear you guys at home. Wait, she didn't do that problem. Um, or maybe you went back up yourself and worked it out yourself. But I meant to come back to this problem and work it now that we have this technique. So this problem was asking how many perfect squares are between 10 and 10,000. And so now we can just, well, the first one would be, well, 3 squared is 9, which is too small. So 5 squared would be the first one, which is 25, right? And the next odd perfect square would be 49. And the next one would be 9 squared, which is 81. Okay, and dot, dot, dot. Now we want to find the biggest odd perfect square that doesn't go past 10,000. And now we know that 100 squared is 10,000, right? So it's not too bad to find the last one that doesn't exceed 10,000 because it's just one less than 100 squared. So 99 squared, that ends up being 9,801. Okay, so the last number here is 9,801. So now we have, we've converted this problem into a how many numbers are in this list problem. And like I said before, look at the gap. Now in this case, the gaps are not even. And that's because we're working with squares instead of multiples. So, so be careful. Don't go trying to, to look at the gap and then dividing by that number, because in this case they won't be even. And I think it's pretty obvious what needs to be done. We need to undo the squaring. So let's do that. Let's take the square root of everything in this list. And so we'll end up with 5, 7, 9, dot, 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 all the way up to 99, right? If we take the square root of everything. And now, if you look at the gaps between the numbers, we have a constant gap. So we have 5, 7, 9. And we have basically all the odd numbers starting with 5. And the gap between the odd numbers is always 2. So we're dealing with something plus a multiple of 2. So we want to divide this by 2. So let's shift it so that we can divide by 2. Now I could add 1 or I could subtract 1, but I'm actually going to, I think this will save some steps if I actually subtract 3. We'll still get a multiple of 2, but we'll get a list that starts with 2 instead. And then when we divide by then when we divide by 2, then we'll get 1. So it'll save us a step if we subtract 3 instead of 1 or adding 1. Okay, so 2, 4, 6, all the way up to 96. Okay, and now everything is divisible by 2, so let's divide by 2, and we get 1, 2, 3, all the way up to 48. Okay, and that's our answer, 48. So we've taken this really kind of tough-looking problem. The thought of having to list out all the odd perfect squares from 10 to 10,000 just seems like it'd be a lot of work. But by using this technique, it's really not too bad, right? It's pretty simple, really. And so this technique is very useful, and you'll find a lot of contest problems that where this technique comes in handy. So good luck with the worksheet, and I'll be posting solutions for the worksheet as well if you have trouble with any of those problems.